Welcome to Lesson 14, Part 1. This will be at least two parts, probably quite lengthy. It's going to be the concept of using the 512K in your machine, if that's what you have, from a basic program or from an assembly language program. This is going to be somewhat, I think, complicated, but I'm going to try to get through it and try to give you some help on using all this memory that you have. When we're done at the end of this lesson 14, we will have a basic program that has a graphic screen, and it will interface with assembly language routines that are in memory, somewhere in memory, out in other blocks other than uh, local memory there, and interface in, flip some blocks around. Instead of talking about that, let's take a look here at what we're planning on doing. If I can find the correct screen. Okay, there it is. I already have the program loaded in memory, so I'm just going to run it. This is a basic program. It's drawing a bunch of lines, creating boxes. It's doing from 0 to 63 or 64 boxes. It's doing a random number for get a color, and it's doing an H print and doing an H paint and an H print to put the numbers in the boxes. That's all. It's all basic. Nothing else has been going on basic. Object of this is not a game. It's just for demonstration. It's taking two numbers. Let's kind of swap them. Let's take two of them. That's easy. Let's take box number 1. I'll put a 1 in and hit enter. And let's use box number 9, which is right below it. Hit enter, and it flips them two boxes. Nothing magic. Basic does ask the questions. It goes over to assembly language program a couple times to do the swap. There's also an option down there at the bottom, which is instead of you typing something in, it will automatically do random numbers that are two box numbers and flip the boxes around. As you can see, it's doing it now. That's the ultimate when we're done with this lesson. I'll hit 99 here and get it out of that and back to our course. Okay, this is for basic programmers who want to boost, or assembly programmers that want to use more than 64K. We did some interfacing with basic back in lesson 12, if you recall. This will definitely be more complicated, but useful for larger projects or lots of graphics. If you got a lot of sprites or a lot of backgrounds, you want to keep bringing them in or moving them around. This was where you give you some help in using that, and it'll be used most or all of the 512K if you would like to. Key to it is a small program. I call it a stub program that will serve as a path to all the features and functions that you have off in other memory. Okay, stub program. It's my name. It's a small program resident in memory. It's there all the time. You load it up whenever you want. It's always in memory. And its purpose is, you can read it there, a clean common interface in between basic or assembly language programs and the assembly language programs that are not in current executable memory. Okay, what that says, you got a program down at 1000 running and you want to bring in some other features or functions that are quite large or does some specific things for you, and they're out in memory. It's just let's say in block 4, this stub program will be able to take care of all that for you and aid in the execution. Okay, I'm going to show you some examples. Now I'm going to use my system for the examples. My system is quite hybrid. It's built over many years. I have pop-up windows, which I'll demonstrate. And one thing we're going to use is I'm going to show you the help text. And I got the 121 there. Okay, that's help, and ask you want math functions, string functions, input output functions, and we're going to do string functions. And within that, we're going to look at string length. Okay, it's a common C routine. You give it a string, and it will come back with the number of bytes within that string. Other functions within them pop-ups, there's dates, palettes, colors, working disk, etc. It's for all use on my system alone, but it will give you an idea how it works. I also have previous commands. I don't know if you're sitting there and you're working on your basic program and you want to get this complicated routine, say at line 100 through 200, and you keep changing stuff, and you got to keep listing that specific line numbers off. You go list 100-200. Well, with my system, every line you put in, you can press F1 and scroll back through the last 75 commands without having to retype it in. I'll demonstrate that. Also, I have dir with the asterisk, which means you can do a search within your directory. So you can do a search asterisk.bas for all the basic programs in the current directory you're working with. There's other stuff, but that's some of the ones I highlight that you probably would think about, and you'll see a demonstration of them. But it also shows what I'm trying to get at here is this, all that code and feature functions is out in memory blocks, okay? I see at the very bottom it's stored out in blocks 7 through 14. Why 7 through 14? I don't know. When I first started coding, the first block I used was 7, and just went on from there, and I got up to 14. It all has lots of code out in them blocks for various feature functions. And it says here, I can write code that can access many of these common functions easily without having to copy, paste, or make my programs so big that they're awkward. Okay, how do we access all this stuff I'm talking about? All right, we got the common.include. Okay, in all of our, or most of our lessons, we've had a common.inc file that has a lot of equates or other stuff in it. Well, the same way with this here. I have all the different feature functions all numbered and are in my common.include file. It's not, mine isn't called common.include, it's called COCO.include, but it's the same thing. We have a stub program that's called common.asm. We're going to take a good look at that one. And the feature functions are in comload.assembler, all the routines, and we'll look at them. But the help text that we're going to be looking at, I'm going to show you here in a second. We're going to demonstrate the system. We'll be using the string link one, and that's how you get to it. But first of all, let's go back over to, again, I got to find the correct screen. There we go. All right, I'm going to hit the F2 key, I think, maybe not. Okay, I get a pop-up window. It's just by hit F2, I get a pop-up, okay? That pop-up code is not in executable memory, but it's off in, and I believe it's in, I don't know. It's not in block 9. It's some other block out there that code is in. But anyway, here's the things that I'd use for my system, okay? The help text. Well, let's look at that one first, okay? Remember I said earlier we'd look at that string length. So if I hit 1 on the keyboard, it gives me another pop-up window that says here's the help stuff, okay? It's got math functions, string functions, in and out functions. So it's common stuff for coding if you're coding in a lot of text stuff. So I'm going to hit 2 for the string functions. Okay, and I don't know who selected these colors, but I think it was me. But anyway, I think it was during the test. I kept trying different colors during my test and never changed them. So there's the help text I have for various string functions. If you've coded in C or Java, you're probably very well familiar with these terms anyway. So I'm going to look at one, string length. That's the easiest one, and it's the first one in there. And there's the help for it. String length, count characters in a string that's in register X. So we've got to point it to register X. Hope I got a phone call. I can hurry up. And the count is returned in register B. All right, I hit the space bar and get out of there. Okay, now if I hit the pop-up window again, there's the other things to do. Now, my system, in my directory, I keep the dates of last usage in there so I know exactly what version is correct. I have other things in there that I use. The number 4 DR, so I don't use that anymore. Thought it was kind of cool when I wrote it 4 or 5 years ago, but I don't use it. But for changing the palettes or colors, it's easy. And number 7 is another useful one. I have all my code is on various disk. I'm using RGB DOS, which has 256 virtual drives. So in different drives, I have different things. I'll hit the 7, okay? And there's the disk. All my system code, the patches and all the things I've done to change the system are on disk 3. Now build command, that's the commands where I store the 75 commands. That interrupts every keystroke you put in. It looks at all keystrokes and does something with them, whether it's the F1, F2 key, or changing various things. And then it keeps track of whenever you hit enter, it keeps the last command in that command file. Common is the things we're going to look at. Here's where the common routines are, all these feature functions. And the stub program is in there. The pop-up code, which you're looking at right now, is on disk 6. It has all the code for pop-up on that disk. In the menu, it also works with the pop-up is on 7, and that's kind of it. So that's kind of what we're going to look at here. What else? Okay, I'll do a dir command. Okay, let's look at that. Okay. Okay, well, let's go back and bring that pop-up window. Okay, I'm going to look at 7 again. I'm going to look at the system disk 3. Let's just go to that drive and then we'll do a dir on it. Okay, so it's got a lot of stuff on there. I mean, what's on there doesn't make any difference. It's got some. That's the master for loading up the system. Okay, now if you get these disks that have a lot of things on them, you want to see I can do a dir asterisk dot. Just look at what I'm going to look, see what basic files are on there. Okay, so I just get a list of the basic files. Likewise, I could do a dir. Anything that has the word patch in it. Okay, we got them 2 files. So that's some of the code that's out there. It's resident memory for use. What other things did I say we could do with this? Okay, let's do dir on 3, dir on 4. I also have that basic program memory, so let's list 100 to 200. Not to think special about it, I could. Let's do a dir on 5, dir on 6. Now I can hit the F1 key. That's the command we just put in, dir6. I hit the F1 key again, dir5, hit the F1 key again, and there's that list again. I hit enter. I can list off that section again. Now I hit F1 again. There's that command, dir6, go back. And this is just doing the last 75 commands. Okay, so that's another example of the system, the way I put it together and the way it works. It's not I'm saying what you're ever going to do, and I'm never going to show you how to do it because it's very, very time consuming. I get years worth of work on this during COVID just to have something to do. Let's go back here and get back to our screen. Okay, now we're going to start looking at some of the code. Okay, again we're going to look at com.asm. That's where the stub is. Now we'll look at the equates, and in this order we'll look at them. Okay, and here's the code to access string length. Is load up the string you want to test, load up A with a common number, and then jump indirect routine. Okay, so we will go to the equates file. This is my common dot equates, okay? And here's all these feature functions that are out there. You all have a number. String length that equates to a 1, string copy to a 2, and you can see them. There's our string functions. Here's some more. Here's some input converting, from decimals and hexes in and out. Here's some divide A by A and B, divide X and Y, multiply B and Y together. Here's some pop up, pop in, initiate random, get random. That's all of the functions is in the stub loader or in the stub functions. Let's take a look now at the stub program. Okay, and all this code, I don't know if you notice any code I did, there's usually a lot of remarks. Okay, and if you look at the data, I wrote this back in 2021. Okay, and if I try to remember what all this stuff is in these programs, I'd never get it changed. So there's a lot of notes here. Plus, I also have text files that have notes on where things are kept. Okay, so this is a common routine that's stored in memory, resident memory all the time, and the address it's stored at is fdog79. You say, why the hell are you at fdog79? Well, if you look at extended basic unraveled, you'll find out around FA10 up through FE00 is open. There's nothing there. Okay, there's 1,000 bytes of memory up there that's not used at all. So I've segregated that and put all kinds of extra routines, common routines, extra stuff up there. And that's where I put the stub program. Okay, the stub program is probably about 75 bytes long. I don't know if I have a count here. Oh, here it is, yeah, 75 hex bytes long. Okay, so this little stub program is up there. It's that common interface. Okay, so that's there. When I start my system up and I do a load M, it will load this stub up in upper memory. Okay, so this is it. You come into that jump subroutine indirect here. This is where you're going to end up, and it's going to push in on the stack. Okay, let's talk about the string length. X had the parameter, so it's going to save that, and the option code was an A, so it's saving them to. Here's some stuff that you may not ever want to do. I'll have to explain this here. I come from an old world of coding on mainframes, big mainframes, okay? Before the internet, 40,000 terminals hooked to a system in Mexico, Canada, USA, for a financial system. And at any one time, we'd have 20, 25,000 of them terminals hooked up at one time, all banging on it for the results. I'm talking about huge mainframe computers, okay? And a lot of these stuff in the financial world is payments. I'm going to use that as an example. I didn't work with the application as far as the loans and the savings and the payment. I worked with the system itself. And to make sure everything was working, you could have 10,000 people at the same time hit enter wanting to do a payment, okay? And there's a payment program. Well, our system was developed with the payment program might be segregated up into 100 or 200 or 500 different programs based on country, state, county, etc., plus the office you were in. But the very first entry program in a payment was program, we'll call it payment, okay? Well, it got locked in memory based on calculations. Every time it was in, it would get higher and higher in a stack as locked in memory programs. Anyway, but you always wanted to make sure it was there. So there was always some kind of a indicator, okay? And that's what I'm doing here. Is there an indicator that is our common functions really in memory? So I want to look at loadx and look at COCO. Again, I'm explaining stuff you may not ever want to know, but you're going to see why I've got it in here. This is my old school programming that guys did for me, okay? So go back to our common file, and you'll see up here, we're going to have a couple of things we'll look at here. We got one here is called COCO. It's dog F8. Again, that's another address in memory that there's not much used up in that area, and I use it for some work areas. The other one that we're going to look at here, we'll be back. This one is our common 1, common 2. That's our indirect addresses. If I haven't lost you by now, I'll keep trying to lose you. So I get back to our program. So to see if our program is in memory, it's going to see if there's 55AA up in that memory address. So how the hell did 55AA get there? So again, confusing. I'm going to go to the actual programs that has all of our code in it. I'm sorry, at the very, very beginning. I'm sorry, that was at the end. The very, very beginning, you do a load M. Now this here is loaded. See up here, this is at startup time. This is loaded into block 9. Okay, but which would be at 4,000. But this here will be loaded up in upper memory at load time. It's going to put 55AA at dog FF8. Therefore, this program knows that the actual functions are in memory. It's not going to branch to someplace if it's not loaded. So that's all there is to check. Has this stuff been loaded? Yes, it has. Branch, it is. Branch to start to. If not, put out an error message. That's all that's for. You don't probably never need it. I'm just very skeptical. My system runs for days on end. I mean days on end without ever rebooting it, okay? But then again, I got all these error checks in there and safeguards. So just old school and had nothing else to do. Anyway, we get to start 2. We're going to push our parm and our options on the stack. We're going to do a branch sub to get page. Okay, so we're up here in high memory in the stub program. Here's get page, and what this amounts to, this routine amounts to here, it's going to get block 9, and it's going to bring it in FFA2 in the 4,000 to 5 FFF range. Okay, it's also going to save what's currently there so we can restore it later on. So it's all it does. It's going to get it block 9 and bring it into memory, which has all of our code into it. Then it's going to do a jump subroutine to common 2. Okay, common 2 is, I showed you in memory, is up there in upper memory 2, and it is, we look at the end of this one here, common 2 is it puts this address in upper memory is this 4,000. So that's basically all that's done. Again, you can hard code all this stuff, but if I ever change anything, all I got to do is change the equate file, and the stuff still runs when I recompile it. All right, so where was we? Was at here, jump subroutine common 2, which when it equates back out to 4,000. So we're going to, now that page is at 4,000, we got our code. We're going to look at our code. Here at 4,000, this is what has been swapped in from page, it's in page 9. And there's a write-up on here about what's in here, and it's going to do some other talk about this $14 bit, which is probably confuse you more. And I should have taken it out, but I'm too, I would say too lazy. It's just, it's not hurting anybody, so I left it in. So anyway, here you get to here with the code, and I have a bunch of work areas. Any program or feature function can use these work areas, and this is a guarantee that they'll be cleared out to null bytes. Okay, so every program has to do to clear it itself. This ensures that they're there. Again, we're going to push these on the stack, our option and our right, and we're going to ensure that the option number is in between 1 and some number. The number is calculated during the compile time how many things are in the table. If not, we'll go back. Okay, now we're going to actually do something. We're going to load up the common table. You can see down here at the bottom is the common table. Let's look at that. That's all the feature functions are in there. Okay, here's string length. It's option number 1. Remember over that equate file, it was option number 1. There is no option 0, but we got a space for it. And there's all the other options that are within our router. Okay, it's just like BASIC does when you put a command in. Okay, it just looks at a table and says I'm going to go there. This is the same thing. And this one here says string length is at 40B6. Okay, we'll remember that. Okay, so we're going to come in here. It rolls up the table. A still has our option number, which was 1. We'll multiply by 2 because each entry is 2 bytes. Okay, Add that to the X register, that will point us to the current entry, which really is here, to that 40B6. And it's going to do something here that you probably don't even care about. I put it in here when I first started coding, because I coded this before the other part. In front of each routine, you'll see there's a $14 to validate that the thing is intact and hadn't been disrupted. Don't need it anymore, but I didn't take it out. It will check that the 14's there. It's okay if it's not. It will do something. So we go back here. We're going to load back up that program entry. We're going to bump it by 1 to get past that $14, and we're going to store the address of the routine in a place called save one, which is just any place, just a memory location. We'll pull our option number and our params off the stack again, and we'll jump to where the address we saved, which in turn for string length is the first byte after the $14. So here's the first instruction. Clear register B, and it goes through this little bitty loop and counting until it finds a null, and then the count is there and does return sub. Now, if we look at what we did up here, we did a jump. We didn't do a jump subroutine. We just did a jump to save one. So when we're done down here with this return sub, it returns back to the last one on the stack, which is back to our original program, our stub program. Comes back here to branch sub, put page back. Put page, all it does is take the page number we saved up here in MM01, it takes that one and refreshes our current memory the way it was, restores everything back, and does a return. And here it does return back to your calling program. So if you was at 1000, you went all through all this stuff and come back there. Now, any smart programmer sitting out there looking at this would say, what in the hell did you do all that for save 8 instructions? I agree. That's all it did. It saved 8 instructions. We went through all that work. Same thing we did string copy. Saved 8 instructions. We did hundreds of instructions, okay? And I realized that after I started coding. Now, if you look at the other ones in here, there's no code in them. It just doesn't do them because I said it's useless. Now when you start getting into some of these other feature functions, like string trim, they're a little bit longer. Okay, this is the trim, so it's longer, so it's useful. It's usable. Two upper, okay, it's easy, or it's nice because it's all these codes, you don't have to worry about them. So, and remember all the functions here have been tried and tested and work. Now you get into some of these other routines in here, like hex in. Okay, if you was to sit at the keyboard and you want a hex address, you type in 1A2B. Okay, that's characters. Okay, that's not hex, that's character. You got to convert it to hex because you want to get $1A2B. You want to get that in register D. That routine will take care of it. You can see why this one's here because it's got all this code. Okay, same with hex out. If you got in your register 1A2B, you want to be able to print it to the screen. Okay, this routine, when you get done, it will have 1A2B in character format. Okay, and that's a long routine. Here's a divide routine. Here's a multiply B by Y routine. It gives you all the multiplier, the multiplicand, and then the division ones, it gives you the remainder. All that's done for you. Here's another one. If you're at the keyboard and you type in 1, 2, 3, 4 and you want to use it in something, you need it to be in hex, so it converts it to the hex routine. So that's in there. Here's a toughie. This is a big one. So you got a game and you're keeping track of the score in a register, and the register has a counter in there of 1A2B, and you want to print, here's your score on the screen. You don't want to print 1A2B. Go to this routine and the output would be 06699, 6699. So this is quite wrong. This is pages of code, okay? Down through there with all its work here. Okay, so I'm just saying the short ones, yeah, it's useless. The big ones, yes, it really saves. You don't have to have all that code, and all this stuff works. Here's the pop-up routine. Okay, when you come in here, you want to use the pop-up routine. You come in here, it has this pop-up and pop-in. Pop-in is another version of, it's a pop-up routine with input. For instance, you pop up a window and say, enter your first name. It's expected some input from you, return it back to the caller. Or if you give me a number from 1 to 100, you input that number, it gives it back to the caller. The confusing thing about pop-ups is we're running here at 4,000 and page 9 we swapped in. Well, pop-up isn't in this page. Pop-up is in page, believe it or not, it's in page 54 or hex 36. That page is the high-res text screen. If you're in a 40-column screen or an 80-column screen, that's where that information is at, the displays on the screen. However, high-res screens, either 40 or 80 characters, only use less than half of that page. So when you bring it into memory, 2 to 3 FFF, high res only uses 2 to 2 FFF. So the pop-up code starts at 3000 in the screen display res page. Okay, it's just a place to save it. So the code is in there. Now, the next problem with it is I need a work area. So you go here, you go to the pop-up at right here, you jump sub to 3000, okay? And when you get to 3000, the first thing it does, it swaps out this 4000 code over here. This page 9, it swaps it out and it brings in, I think, a work page, page 20, so it can use it for the pop-up, not the routine, the code, but actually you need extra workspace, so it uses that and does the pop-up, which you see on the screen. When you're done, you hit the space bar, you're done. It swaps that back out, swaps this page 9 back in, and does the return back to this code here. Confusing? Yes, but it actually works. But you have to, because working with this system on 64K and most of it's in use, you got to keep track of what you're doing and swap them out. And it's done, it goes back to caller. Okay, here's this get random routine. It's better than the base one. Anyway, that's how you get through all these routines. Okay, when you're done with these routines, they come back here, and it goes back to our other original program, which was the stub program. Goes to comment 2, comes back again, puts that back there, and goes back to the caller. Now I know that's confusing, but if you maybe watch this here 1 or 2 times, you'll understand it. Okay, it's confusing, and to get it coded, the testing was unbelievable. But we're not going to do anything like that in what we're coding. We're going to do something very similar, but we're going to do a code like that. And if you ever decide you're going to do something of this nature, you want to look at keeping yourself a list. This is my cheat sheet, okay? It has all the different things in memory and where stuff is used, what blocks are used by what, where it's at, okay? Other notes on where the different screens are, all the different task registers, and that memory I kept talking about, it had stuff at DFFF something and FFF. I got all that stuff in one place because, believe me, if you're using all this stuff, you better know where it's at because you can definitely wipe yourself out. Okay, enough said about that. That's your own character or coding rules and regulations that you want to use. So I think I can kind of end this part 1. It's been long and lengthy and confusing. Let's go back to be sure. Yes, okay, that was the end of it. Maybe hard to follow. Yes, it was. I hope I got it out there. Watch, if you have to, watch it 2 or 3 times. Remember, this is a concept, okay, and that's all it was. Don't worry about how confusing mine is because that's what I did. Okay, I had to do something during COVID, so that's what I did. Anyway, I'm going to end this one here. Look for part 2, which we'll go back. We'll do that. The actual basic code and the code for swapping that stuff around on the space, which is much, much simpler than this here. So with that, we will say, if I get to my screens here, good luck and see you in part 2.